two flight control surfaces are part of the high-lift control system: the leading edge slats and the trailing edge flaps. In this sixth part of the series, we will understand the flap mechanism. The 777 has 4 flaps: 2 single-slotted, outboard flaps, and 2 double-slotted, inboard flaps. The flaps are fly-by-wire controlled, and has 3 modes of operation. The flap position is controlled by using the flap lever. The lever has multiple positions, for different slat and flap configurations. Position transducer keeps track of the current flap lever position. Change in lever position causes the transducer position signal to change. The signal is received by the flap slat electronics unit computer. The flap computer engages the primary mode. Flap lever position 1 results in slat movement. Since we are interested in trailing edge flap movement, let's skip to flaps 5. In position 5, the computer will operate the flap power drive unit. Signal is sent to the hydraulic control valve. Aircraft center hydraulic system pressure is used to operate the flaps. The valve opens to run the hydraulic motor. The motor turns the PDU gearbox, connected to the torque tubes. The torque tubes will now drive 4 transmission assemblies on each wing. The transmission assemblies rotate the ball screw using the torque tubes input. The torque tubes cannot run straight from the power drive unit to the last transmission assembly. Therefore, tubes are rerouted with the help of angle gearboxes. Of the 4 transmission assemblies, 2 will move the inboard flap. The other 2 will move the outboard flap. Let's see how the transmission assemblies extend the flap. The ball screw rotation moves a nut. The nut is connected to the drive arm. The drive arm moves the carrier beam, and the flap extends. Flaps 15. Similar mechanism extends the inboard flap. Two position sensors, one for each wing, measure the torque tube rotation to help the flap computer determine the current flap position. Flaps 20. When a flap position change command is given, the position sensor signal helps the flap computer to stop the movement once the flap has reached the selected setting. The inboard flap is a combination of 2 parts: main flap and the aft flap. When the lever is selected to flaps 25, as the transmission assemblies extend the inboard flap, mechanical pushrod connections will deflect the aft flap more than the main flap. The final flap lever position 30. If the commanded flaps fail to deflect, due to hydraulic system failure, the flap computer will automatically switch to the secondary mode. In secondary mode, the FSEU will command the power drive unit electric motor to operate the flaps. The primary flight computer receives the flap position data from the FSEU. This allows the PFC to droop the flaperons and improve low-speed performance. The PFC also droops the ailerons in some flap positions. Now let's retract the flaps to the up position. Retraction process is similar to extension. Lever command is received by the flap computer. The computer will run the motor in the opposite direction. This will reverse the torque tube rotation and the flaps retract. If a flap computer, or any other component failure, prevents the system from working in the current mode, then the alternate flap switch can be used to extend or retract the flaps. The system must be armed before using the alternate switch. Arm switch will send a signal to the FSEU to disengage the current mode, and the computer will stop controlling the flaps. Let's continue flap retraction using the alternate switch. When the alternate switch is used, a direct signal is sent to the electric motor to retract the flaps. The switch must be turned off after flaps have reached the desired position. The next chapter will be on the leading edge control surfaces. Thanks for watching.